In this lesson, I'm going to walk through the entire process of factoring out a greatest common factor from a given expression. I did a previous lesson video on working primarily on those third and fourth steps, but today I'm going to actually walk through the entire lengthy process with two example problems that are pretty difficult. I chose two that are actually have a high level of difficulty, so that way you can see an example of what the process might look like in full. So our first step in factoring out a greatest common factor is to, given an expression, actually find the greatest common factor between each of the pieces, okay? And remember, we call each of the pieces in an expression a term, and terms are separated by plus and minus signs. So in this example right here, I actually see 1, 2, 3 terms. So we need to find the greatest common factor between each of those, okay? So I'm actually going to go ahead and just rewrite them right here, providing lots of space. So 24r to the power of 6, 3r to the power of 4, and 15r to the power of 3. And note that I just kind of ignored our subtraction signs for right now when we're finding the greatest common factor here. So the first thing to do is let's list the factors, the F part of GCF. So in order to list the factors, I need to figure out what things I can multiply together to get each of these numbers. So let's start over here with 24. Okay, the first, perhaps most obvious factor, that things I can multiply to get 24 would be 1 times 24. And if you don't know off the top of your head, remember the next thing you try is the next biggest number than 1. You say, can I do 2 times something to get 24? And if you don't know, you take your calculator out and you do 24 divided by 2. And you ask yourself if you get a nice whole number. If you do 24 divided by 2 in your calculator, sure enough, you should get 12. So 2 times 12 is 24. The next biggest number after 2 is 3. Next biggest whole number. So we'll try 3. Can I do 3 times something to get 24? Again, if you don't know off the top of your head, you take out your calculator and you say, can I do 24 divided by 3 and get a nice number? And the answer is yes. 24 divided by 3 is 8. So 3 times 8 is 24. Next biggest number after 3, you try 4. You say, can I do 4 times something to get 24? Yep, we could do 6. Next number after 4 is 5. Now you say, can I do 5 times something to get 26? Okay, if I were to take my calculator out and do 24 divided by 5, I would not get a nice whole number, so we know 5 is not going to work. Next biggest number after 5 is 6. Oh, but what 6 times what gets us 24? 4, right? And you can see up here on this line, I already wrote 4 times 6 or 6 times 4. Order doesn't matter when multiplying, so we've already listed those factors. So if you remember, once you see the same number here that you see here, you're done. You found all of the factors of that number. So 24 is done as far as the numbers. Let's go ahead and move on to 3, r to the power of 4. This one's a lot quicker. There are only 2 things that multiply to get 3. 1 times 3. So that one's quick. Scroll over to this guy here. 15. What numbers can I multiply to get 15 is the question. So I know I can do 1 times 15. Next biggest number is 2. That's a whole number. Can I do 2 times something to get 15? You may say, I don't really know, Mr. Winchell. So we'll do 15 divided by 2 in our calculators to see if we get a nice whole number. And we don't, right? We do not get a nice whole number. So there's nothing 2 times, there's no 2 times a whole number that's going to get us 15. Next biggest number after 2 would be 3, though. And I do know that indeed 3 times 5 is going to get me 15. Can I do 4 times something? Well, maybe if you don't know, you get out your calculator, do 15 divided by 4, see if you get a nice whole number, and you don't, unfortunately. So we can't do 4 times something to get 15. What about 5? Oh, well, if you remember, when I see the same thing here that I see here, I'm done. I've already found all my factors, because I know if I do 15 divided by 5, I'll get 3. We already have 3 times 5, same thing as 5 times 3. So we've listed all the factors as far as the numbers are concerned. Now we need to go and take a look at the variables that appear in each column here. So I can see this first one, 24r to the power of 6, means that I have 6 r's multiplied together, right? 1, 2, 3, 4, 5, 6. But that's it. R is my only variable. Now looking right here, r to the power of 4 means I've got 4 of them multiplied together. 3, 4. And then on my third and final term here, r to the power of 3 means I know I've got 3 of them multiplied together. Okay, so we've listed the factors. We've done that f part of greatest common factor. Right, so that guy's done. Now we need to find what's common. So let's take a look at the numbers, and I'm going to circle what's common between each of these here. Let's do this in green. So let's say I have to find something that appears in all 3 columns, right? So I see a 1 there, and there, and there. So that's common. I see a 3 here, here, and here. And those are the only things that are common between each term there as far as factors are concerned. So just 1 and 3 are the only things I can put into each one evenly. Then you ask yourself the greatest part, right? So we did factor, we did common, we're just looking at the numbers for right now. Now let's figure out what's greatest. Well, between 1 and 3, which number is greater? And you'll probably say the number 3 is greater than 1. So 3 is the greatest common factor. That's the largest number that goes into 24, 3, and 15 evenly. Next step is to figure out the variables, okay? And remember, when we're trying to figure out what variables we can squish into each of these pieces, each of these terms, we're just going to start over. You can start with any of the terms, but let's see, I can put an R into each piece. I can put at least a single R. It looks like I can also put a second R into each piece. So I'm going to circle a second R. And it looks like I could stick a third R into each piece. Now take a look really quick. I could continue to put more R's into this guy and more R's into this guy, but I can't put any more R's into that guy, right? 3 is the most I can squish in. So the question you're asking yourself is, what's the largest number of R's that I can squish into each piece? And the answer to that is 3, which we'll write as r to the power of 3, because it's r times r times r. So your final answer as to what's the greatest common factor, or the GCF of all of these terms, and it is 3, right, the number 3, and r to the power of 3. That's the largest thing we can squish into each one of those pieces, is 3r to the power of 3. So I know that seemed like a lot. All of that is just step 1 though, okay? Step 1 out of 4 where we find the greatest common factor. So we did that one. Now we need to do step 2, which is to divide that greatest common factor out of each term, okay? So we found the greatest common factor of 3r to the third. Now I'm going to take, now I'm going to take my original 3 terms that we wrote all the way up here, and I'm going to do some division here to see what's left when I take the greatest common factor out of each piece, okay? So I'm going to rewrite them right here. We've got 24r to the power of 6 was the first one. Then we've got 3r to the power of 4. And then we got 15r to the power of 3. And notice I'm leaving some space, and I just ignored the subtraction signs for now, right? Those will come into play at the very end. So I'm going to be dividing 3r to the power of 3 out of each piece. And here's where your quotient property of exponents comes in handy. And this is why we practiced that for so long. So let's see what we get. Right here in this first one, I'm going to do 24 divided by 3, right? I'll divide the big numbers first. If I do that in my calculator, I know I get 8. And here I'm going to do r to the power of 6 divided by r to the power of 3. Okay, if I've got the same base, I know I can subtract my powers. So 6 minus 3 is 3. I've got 8r to the power of 3 left. In the other video, I do show you guys how to do it the long way, right? Where you write it out 6 times, and then you cross off if you see on both above and below the bar. Okay, but we'll just use our quotient property of exponents here and make it more simple. Okay, let's take a look at that second one there now. I'm going to do 3r to the power of 4 divided by 3r to the power of 3. 3 divided by 3 gets me just 1, okay, which we can write. We don't need to write the number 1. But 1, and then r to the power of 4 divided by r to the power of 3, I can just do 4 minus 3, which gets me a 1. So it's r to the power of 1. But again, we don't need to write that power of 1, right? It's implied. And we don't need to write that 1. It's implied. Because you look at that and say, how many r's? Well, there's 1 r. Final third term here. Need to do, let's divide the big numbers. 15 divided by 3 is going to get me 5. And then r to the power of 3 divided by r to the power of 3, Well, 3 minus 3 is 0, or you could look at it like this, right? If I had 3 on top of the bar and 3 underneath my fraction bar, boom, 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 I've got no r's left, right? I was able to cross them all out. So we're just not going to write anything. Note, if I wrote an r, that's r to the power of 1, not r to the power of 0. So we can't just write an r. They're gone. We just have 5 left. So now we completed step 2 there, where we were to divide the greatest common factor out of each term. So I'll put a check mark there. Step 3 is to take that greatest, so sorry, really quick, I've got something written in green here, right? The greatest common factor there written in green. And then I have what was left once I did my division over here written in blue. And I'm going to kind of combine these pieces together, and here's how that works. We're going to write the greatest common factor outside a set of parentheses. So there's my green greatest common factor. I'm going to write him 3r to the third. Actually, let me make sure I'm not running into the, I am a little bit, that's okay though. 3r to the power of 3. And I'm going to write him outside a set of parentheses, leaving lots of space to put some stuff inside. Now let's see what step 4 is. It says step 4 is to write what is left inside the parentheses. So what was left was that stuff in blue when we divided it out. So I'm just going to take my items in blue here, and I'm just going to write them here, leaving space to write a symbol in between each of them. Okay, so there's 8r to the third, r, and 5. Which this is how it should work every time. If I started with 1, 2, 3 terms, I should have 1, 2, 3 terms inside my parentheses as well. Okay, if you don't, that means you lost one at some point. Now I need to take a look back up at my original problem here, those original terms, and see what the signs were on each of those pieces. So the first piece was positive, so that 8r to the third should indeed be positive. That looks good. Second piece, though, is negative, right? Negative 3r to the fourth. So I know I need to have a negative sign right there in between those two. And then the final piece, negative 15r to the third, so I know that needs to be a negative 5. And what I've got down here along on the bottom that I'm about to circle in orange is your final answer, that whole piece. It's a little more complicated, right? There was a lot more involved in this one. Let's take a look at this guy right here. I'm actually going to move him down a little bit, so that way we have plenty of room to actually solve this problem. Down a little bit more. Okay, this one you can see we've got 2 variables going on, so that does make it a little bit more complicated, but the overall process is the same. So don't let it freak you out too much. And I won't give you guys too many problems to do on your own that have 2 variables. So 18xy squared and 24x to the fourth, y to the third. And we've got 30x cubed y squared. And note again that when I wrote these out, I just ignored the negative signs, right? There's one negative sign there, and we're just ignoring it for now as we're finding the factors. So again, I'm going to find my factor pairs. Ask myself, what times what can I get to 18? I can do 1 times 18, 2 times 9, 3 times 6. Can I do 4 times anything? Well, if I don't know, I do 18 divided by 4. And I know when I do that in my calculator, I do not get a nice number. So nope, can't do 4. What about 5? Nope. 6? Oh, well, I already have 6 in my column here on the right-hand side. So I know that we're all done. We found all our factors of 18. Now let's find the factors of 24, which we could, I believe, I had, yep, 24 was the first number we did, so we could cheat and just copy all of those factors that we already found. Do feel free to do that when you're working on your homework or even on the exams. You know, don't do any more work than you have to. So if you recognize a number and you're like, well, I've already found the factor pairs for that number, just go and copy them exactly as you did before, exactly what you had before. So there's all the factor pairs of 24. And then let's take a look at 30 here. I know I can do 1 times 30. Can I do 2 times something to get 30? If I don't know, I take my calculator out, I say 30 divided by 2 gets me what? If you do that in your calculator, gets you a nice even 15. So 2 times 15 gets us 30. And then what about the number 3? Yep, I'd say that we could do 3 times 10. 4? Nope, not so much. If you do 30 divided by 4, you're not going to get a nice number. What about 5, though? Can I do 30, or 5 times something to get 30. If you're not sure, again, take out your calculator. 30 divided by 5. Does it equal a nice number? It indeed does. It'll get a 6. What's the next biggest number after 5? That's a whole number. Well, that's 6. So we could do 6 times what? But then you say, hey, I already did 6 times 5. Right? We already have that factor pair. So I see the same number in both columns. I'm done. Found all the factors of 30. Now let's go ahead and take a look at our variables here. So let's start at 18xy squared. Remember that the exponent, this power of 2, only belongs to what it's right next to. If there were a set of parentheses, that would be different, but we don't have parentheses. So only the y is to a power of 2. So you ask yourself, how many x's are there? Well, just a single x. How many y's? 2. Y times y. Y multiplied by itself twice. Okay. Let's take a look at that middle term there. I see how many x's. There it's to a power of 4, so I know that's x times x times x times x. How many y's? Power of 3. Y times y times y. Let's take a look at this final one here. How many x's? Well, it's to a power of 3, so I know there's 3 of them. How many y's? It's to a power of 2, so it's y times y. Now let's go ahead, let's just start with the numbers here, and we'll find the greatest common factor with just the numbers first. So what's in purple? So we found the factors. Now we need to find what's common. Remember, it needs to occur in every single column if I'm going to circle it, okay? So just because I see an 8 in one column, or a 6 in one, but not the other 2, I can't circle it, okay? It has to appear in all 3. So let's see, I see a 1 in every single column here. I see a 2 in every single column here. Pretty fortuitous so far. I see a 3 in every single column. It's kind of nice. I also see a 6 in every single piece. 6 can go into each term evenly. And that's about it. Those are the only numbers I see that occur in every single one, in all 3 of them. Okay. So we found the factors, we found what's common. Now we need to figure out which one's greatest. So between the numbers 1, 2, 3, and 6, you ask yourself which one's greatest, and it's pretty obvious, right? The number 6 is the greatest between all of those. So we know at least we found part of our GCF. We know the number 6 is going to play a factor. Now we need to go through and see, as far as our variables, what's common. So we're going to know what's the most we can squish into each piece. Let's start with the x's, okay? And I'm actually going to work backwards here on purpose just so you can see. So I see in this first one on the far right, I can put an x into that piece, and I can put an x into that one, and I can put an x into that one. Then we could almost continue going, right? And we'd say, oh, I can put another x into that one. I can put another x into the middle one. But oops, can I put another x into that one? Nope, I sure can't. So I got to erase those because I can't put an x into that one. No. Let me recircle that. So that's the most we can put into each one is a single x, okay? Because this one on the far left has only one x in it, so we can't put any more in. Now let's take a look at our y's. I see I can put a y in that one, I can put a y into that one, I can put a y into that one. Now we can continue. I can put a second y into each piece, right? Put a second y into each piece. And this is where I see common mistakes. At the very end here, we need to ask ourselves, what's the most we can put into each piece? So what's the most we can put into a single piece? Okay, because yeah, you might say, oh, I've got 3 x's circled. So it should be x to the power of 3, right? But no, you're asking yourself, how many can you put into a single one? And into a single one, I can only put a single x, okay? That's all I can put into each piece. I can't put an x to the power of 3 into my x to the power of 1 that I have on the far left. So it's the most we can put in, an x. Now what about y's? What's the most we can put into a single piece? Just 2 of them. And I note I write that as y to the power of 2. There's no power of 2 on x. The power of 2 only belongs to y, to what it's immediately next to. So we finished step 1 there, which is find the greatest common factor. We go ahead and erase these. So we did that. Now we need to work with step 2, which is to divide the greatest common factor out of each term. Again, so that's where I'm going to rewrite all of these guys over here. I'm just going to take each of my terms that I have in red, and I'm going to write them right here, making sure to leave space so that I can divide each of them by the greatest common factor. The greatest common factor that I've got written there in green, 6xy squared. 6xy squared. And divide by 6xy squared. And now we're just going to run through and see what we get out of each one of these. So let me zoom in on that first one. Let's apply those exponent properties again. It looks a little more complicated because we've got two variables going on here, but same process. We'll take a piece at a time. So here, let me do 18 divided by 6 first. I know when I do 18 divided by 6, I get the number 3. Now x divided by x, right? There's not a power of 2 on the x, so make sure you don't do that. The power of 2 belongs to the y. So I just have an x on top and an x on the bottom. They cross out, so I don't have any x's left. Okay, or you could say x to the power of 1 divided by x to the power of 1. We do 1 minus 1 and get 0. And the same thing is actually going to happen with my y's here. I've got y to the power of 2, which is y times y, and y to the power of 2, which is y times y. If I cross them out, I have no y's left. So our final answer when we do that division piece is just a 3 there. Nothing else left. Kind of nice. Let's take a look at the second one here. Again, I'm going to divide the numbers first. And if we found the correct greatest common factor, this should work out nicely every time when we do this division piece. So 24 divided by 6 is going to be 4. Okay, now we're just going to take a look at the x's first. Okay, I can't say, oh, x to the power of 4 divided by y to the power of 2 gets me xy2. No. All right, we got to take it piece by piece. So x to the power of 4 divided by x to the power of 1 gets me x to the power of 3. Right, 4 minus 1 is 3. Now let's take a look at the y's. Y to the power of 3 divided by y to the power of 2. I can just do 3 minus 2, which is 1. So I have y. You could write y to the power of 1, but remember it's implied that there's a power of 1. Final piece. Let's divide the numbers first. 30 divided by 6 is going to be 5. Now let's take a look at the x's. X to the power of 3 divided by x to the power of 1 gets me x to the power of 2. Okay, 3 minus 1 is 2. And then over here, let's take a look at the y's. I've got a y to the power of 2 over a y to the power of 2, which those end up canceling out, right? 2 minus 2 is 0. So I don't have any y's left. So believe it or not, we've already completed that step 2 where we divide each term by the greatest common factor. Okay, or divide the greatest common factor out of each term. Same thing. Let's move on to step 3. Write that greatest common factor, which I have in green, outside a set of parentheses, which I'm going to do in black down here. So the greatest common factor is what I have in green there, and I'm supposed to take this guy and write him outside a set of parentheses. So 6xy squared, that whole thing, outside a set of parentheses. Again, leaving lots of space. That was our step 3. So we did that guy. Boom. Finally, we need to write what is left. What was left was that stuff in blue after we divide it out. So we're writing what's left after we divide the greatest common factor out of each term. What's left inside the parentheses. So that's where each of the items here I wrote in blue on the far right are going to go into the parentheses. Okay, and I'm making sure to leave room to separate the terms. So there's 3. There's 4x to the third y, and there's 5x squared, leaving lots of space there. Because now the final step is to look back at my original problem, look back at those terms, which look really tiny compared to everything else I've written, but I'm looking way back over here at the original ones to see what the signs were on each piece. So I see the first one's positive, second one's positive, third one's negative. So it should follow that same pattern with what I'm writing in my parentheses here. So it should be positive 3. That's good. We'll just leave that. That means we don't have to write a negative in front, but we don't really need to write a positive. Okay, the second one's positive, so I'll write a plus symbol in between. And then the last one's negative, so I'll write a minus sign in between. And this guy that I'm about to circle in orange, this whole thing, let me move over a little. This whole thing is my final answer. 6y squared, or 6xy squared times the quantity 3 plus 4x cubed y minus 5x squared. And I promise if you were to do the distributive property, do that rainbow rule and multiply that guy by each piece that's inside here, we would end up with exactly what we started with at the beginning. So that was just me running through the whole process on 2 examples of how you will factor the greatest common factor out of an expression. Today I need you to work on problems 7 through 12 on the worksheet, which are more complicated ones, just like these 2 examples I just covered today.